see, F into H star is equal to rho G into I naught, right? Yes. Now we know F is equal to rho G A into H bar. Just to I'll substitute that. Rho G A into H bar into H star is equal to rho G into I naught. So what I want this H star, right? Center of height of the center of pressure. H star is equal to rho G I naught divided by rho G A into H bar. So this rho G goes. So H star is equal to I naught divided by A into H bar. Okay. This H star is equal to I naught into A H bar. Now, you already know this concept also, which I am introducing now. We know that by the theorem of parallel axis, we have one formula. We have studied in this in first year. What is that? Theorem of parallaxis. That is, I naught is equal to, I am writing with respect to the derivation now. Okay, I naught is equal to Ig plus A into H bar. By the theorem of parallaxis, I naught is what? The moment of inertia of the surface here only, okay, is equal to the Ig what? Moment of inertia of area about an axis passing through the center of gravity. So this is the moment of inertia of that surface. Ig is perfectly for, this is the Ig. First I will write what is Ig. Ig is what? Moment of inertia, okay, of area about an axis passing centroid G through CG. So our CG is what? So we have already taken that G is the centroid of gravity of the surface. So G. So H bar is the distance for this G. Okay. So Ig is also Mi of area about an axis passing through the centroid G of the area, and parallel, and it is parallel to the surface of liquid. So now what is this Ig and I naught? What is this theorem of parallaxis? Please go to the elements of engineering section and go to the centroid chapter. There I have explained this theorem also in my channel only. Okay, go to the playlist of elements of civil engineering. In that you have a bunch of videos under the module 4 centroid from the first year. You can get the video from there and you can understand about the this I naught and all. Okay, moment of inertia and all. So now Ig is what? It is parallel to the surface of the liquid and it is passing to the centroid G. So by this equation, what we can do here, so we just take this equation. So I will take this equation number as 4. So from equation number 4, I will just replace the I naught value with Ig. So here in the theorem it is difficult, but this will help us when we solve the problem. We can get the values directly. How? I will let you know. Because we have calculated the centroid, the Ig moment of inertia of every geometrical figure, that is square or rectangle or circle or semicircle, all we have done in your first years. Okay, so H star will be, in the place of I naught I will write Ig plus area into the H bar divided by A into H bar. So if I solve more, I will get this Ig divided by AH bar, okay, plus H bar. So this is the height of the center of pressure. Okay, in this equation, so this is equation number 5. So this equation number 5, in this equation number 5, h bar is what? It is the distance. It is the distance of center of gravity of area of vertical surface. I have already written. So h bar, distance of center of gravity from free surface. Hence, from this equation, we can note two terms. Hence, from this equation, it is clear that, so what is clear? First item, that the center of pressure, that is the height h star, okay, lies below the center of gravity of vertical surface. Okay, this h star, because when we add something Ig, when we add h, see, h bar is what? Distance of Cg. Okay, for this, if we add this term, we will get this term. Okay, h star ಗೆ ಈ ಟರ್ಮ್ ನ h star ಬೇಕಂದ್ರೆ h ಬಾರಿಗೆ, ಸೊ h dash ಅಥವಾ h ಬಾರಿಗೆ ಈ ಟರ್ಮ್ ಆಡ್ ಮಾಡಿದಾಗ ನಮ್ಗೆ h star ಸಿಗುತ್ತೆ. Means this h star is what? Bigger. This h star what? Lies below the Cg. ಈ ಡಿಸ್ಟೆನ್ಸ್ ಗಿಂತನೂ h star ಜಾಸ್ತಿ ಇರುತ್ತೆ. COP lies below the center of gravity of vertical surface. We have to note it down that center of pressure h star lies below the center of gravity, because this h for some item we have this value Ig by A into h bar have to be added to h bar to get h star. Okay, to get this term we have to add this item to the h bar, so it is greater and it lies below the center of gravity of the vertical surface. Second item is, so this distance of h star, it is independent of density of liquid. See, in this formula, any density rho is there? No. Okay, because the density is not there in this formula, we can tell that the equation for this distance h star, what is this h star? H star is the distance, see, this distance h star, okay, distance of the center of pressure from free surface of a liquid. It does not depend upon the density of the liquid. Okay, it does not depend upon the density of the liquid. Okay, it is independent of the density of the liquid for whichever liquid we are calculating. Fine, these two terms we have to know, and this may be asked in your GATE exam too. Okay, what is that? The center of pressure h star lies below the center of gravity of vertical surface. G ಕಿಂತ ಕೆಳಗಡೆ ಇರುತ್ತೆ ಇದರ height, ಏನು, center of pressure height C. Then the distance of h star, it is independent of the density of liquid. So this was about the vertical plane surface submerged in liquid. So we took the figure and we assumed some values. Just we go on balancing our equation. We took our basic pressure equation rho gh and we just added the term which we know, common terms, and we just, so for that common term only we got what? Total pressure. But when calculating the center of pressure, we have to do some, we have to concentrate more. That is, we here want another concept of principle of moments. That is, the resultant force is equal to the sum of all the moment of all the components. So the moment of force, so B of F about the free surface, it is for F for the free surface, it is equal to what? It is equal to the sum of the moment of all the forces which are acting on the strip. So many strips will be there in that free surface area which is submerged in the liquid. So what we did, we calculated the sum of the moment about the free surface, that we got as rho g I naught. So this rho g I naught and the F into H star, what we did, we according to the principle of moments, we equated it. We equated and we got the value of H star, that is I naught by A H bar. But from I naught we can't, in the doing problem, when we solve the problems in future, you will come to know we can't find I naught value. Okay, for all the figures, all the geometric figures, that mean rectangle, triangle, circle, semicircle, we can't find for each and every term I naught. But what we have found, we have already found that Ig value, that is for square rectangle you can take, that is BD cube by 12, like that, BH cube by 36 for triangle. We already know the moment of inertia value for some geometrical terms, okay, for some geometric properties of geometric figures. So what I did, in the place of I naught, by the theorem of parallaxis, I added Ig plus A into H bar. So this is the theorem, we already proved it in our first year. So in the place of I naught, I added H star is equal to Ig divided by A into H bar plus H bar. So I got the H star value. So H star is equal to Ig by AH bar plus H bar. So this was about the derivation. May be asked in the exam to find out the total pressure of vertical plane surface submerged in liquid, or you may also ask for the center of pressure. But to do the center of pressure equation, to find this H star, what we want this total pressure also. So once you practice, you can write it in very concise and compact way. You no need to write 2 pages. You can conclude in 1 page only if you know the concept. Okay, to know the concept, I made this derivation that up to 2.5 pages. Okay, now we will go to the next equation, that is for horizontal one, which is a small one. So I'll write the headings. So I'll write here only. So it is very small derivation. It will be not asked. Okay. So what we did for vertical plane surface. Now second item. So what I do, I calculate for horizontal plane surface. Okay, submerged in liquid. Vertical plane surface. If there is a vertical plane surface, what we did in the above process. Now if there is a horizontal plane submerged in the liquid, what we can do? So I'll show you, very small it is. So see, from the red pen only, black pen I'll take. Okay, so I'll consider a free surface. So I'll consider this as the free surface of liquid. So below this water is there. Okay, so consider it as a water. Okay, now what we want a horizontal plane surface. So for vertical I directly showed you. For horizontal, how can I show you? So it is plane, right? So it will also be plane. So I'll take cross items. So the plane, okay, I will consider this as the horizontal plane. So as the free surface is there, like that only this horizontal plane will be there. Okay, what about vertical? I can see directly from here, from my view is like this now. Okay, I can see the vertical, but for horizontal I have to take like this cross only. So what I can write, so its axis, so this is and this may be its axis. So for this horizontal surface, so we will write the story now, what we did and what we have doing now. Okay, so what we can write the story, consider what? Consider a plane. I'll write it in very short way. Plane surface immersed, okay, immersed in static fluid. As this is the horizontal plane, okay, as this is the horizontal plane, here what happens means at every point of the surface, every point on the surface is at the same depth, is at the same. Please imagine here, if what I can show you, see this is the calci. So if I consider this as a plane surface and this as the plane surface submerged in the liquid, this is plane surface submerged in the liquid, and this is what? Free surface of the liquid. So free surface is like this, okay, free surface is like this. Below this what is there? There is plane is there, okay. So this is what the system is. What I do, I just rotate both, okay. Now what you can see, the free surface of a liquid is this one. 1 minute. See here. Free surface of liquid is this one. This is what? The plane, horizontal plane. So when it is submerged in the liquid, every point, okay, every point on this free surface, okay, every point from here, the distance between this plane surface and this free surface is what? Same, okay. See here, 0.25 of this pen, 0.25 of this pen. So at everywhere the height of every particle on this surface, on this plane surface to the free surface of a liquid will be same, okay. I'll write that point, that is, as every point of surface is at same depth, okay, is at same depth from free surface of liquid, okay. Every point here, it has a same height. The surface, the free surface will also be like this only, okay. So in paper I can't show that, okay. So the pressure intensity, so due to height is same, as height is same, what about pressure intensity? This pressure intensity will also be same, because what? P is equal to what? Rho g h. As height is same, P is also same. Rho g are what? They are the, rho is liquid constant, whatever the liquid is there. G is the acceleration due to gravity, okay. So as every point on surface is at same depth from free surface of the liquid, the pressure intensity will be same, okay. That is, P is equal to rho g h, and h is what? Depth of surface, So now I'll consider, let A as the total surface area, okay. If there is a total surface area, then what about this center of P and what about this G? They both lie on the same intersection, they both lie here, and what will be the depth? The depth will be same. So what is the depth associated with the center of G? It is h bar. What is the depth associated with this P? It is h star. Here this both h bar and h star will be same for the horizontal plane surface. So then here I can directly write, then the total force, F on the surface is equal to what? Pressure force into area, which implies, what is this P? Rho GH into area. What about this H? This H may be this H bar or H star, anyone. So I'll write in the next page. Two lines are there. So the total force F is equal to what? Rho GH into area. So F is equal to what? Rho GA into this H may be, I'll take as H bar due to the center of gravity, and it may be also be taken as, F can also be Rho GA into H star, where H star is what? Distance of CG of the COP, center of pressure distance from the free surface of a liquid. But here this H bar is equal to what? H star. So it is okay. Anyone you can take. So generally what we can write for the horizontal surface, if it is submerged in liquid, we will directly calculate as F is equal to Rho GA into H. Okay. And this H and H bar and H star are the same values as we took in the previous, that is distance of center of pressure from the free surface. This H is the distance of, H bar is the distance of CG of area from the free surface. So directly we can get here that F is equal to Rho GA into H. It is the total force. So this both P, what is this P? Center of pressure, the point of center of pressure, and the center of gravity G, both lies at same plane. So no necessity to find H star value, no necessity to find. If you get this total pressure, it's enough. So this was about the two derivations for today. Next we will solve some of the problems on this, and we'll go to the inclined plane surface submerged in liquid and also the curved plane surface submerged in liquid.